What would you think if an object in space, one we were told was a comet, suddenly revealed straight lines, sharp edges, and a shape that looked engineered rather than natural? This isn't a thought experiment. It's the question astronomers are asking right now, and not casually, because something inside our solar system is behaving in a way no comet should, ignoring the rules, defying the models, and forcing even the skeptics to reconsider what they thought they knew. Let me show you why. Start with two photographs. On the left, an image captured by amateur astronomer Diego Santaraujo. Crisp, detailed, showing clean geometric edges and a structure that holds its shape from frame to frame. On the right, NASA's official release, blurred, washed out, revealing almost nothing. Same object, same night. Yet the amateur's backyard telescope produced more clarity than NASA's space-grade systems. Why? That question alone should make anyone pause, and it's only the first sign that something about this object doesn't fit. Look again at Santaraujo's image, the straight lines, the fixed angles, the stable form, and then the detail that shocked everyone, the complete absence of a tail. Comets always have tails. Solar wind pushes dust and gas away from the nucleus. It's the most basic, predictable feature of a comet. But this object shows none of it. Instead, it emits sharp X-shaped bursts from specific points, not a diffuse plume, but directional ejections that look less like random venting and more like controlled thrust. And then came the solar flares. As it moved toward the Sun, the object passed through multiple X-class flares, the kind powerful enough to shred fragile comet nuclei into dust. We've watched countless icy bodies disintegrate under far less extreme conditions. But this one didn't break apart. It didn't brighten, dim, drift, or wobble. Its structure didn't crack, its trajectory didn't shift. It simply continued forward, steady and intact, as if the most violent radiation in the inner solar system barely touched it. And remember, none of this is old news. These events unfolded in just the last few weeks. This is happening right now. Atlas is only the third interstellar object ever observed, after Oumuamua in 2017 and Borisov in 2019, and astronomers expected it to behave just like the others. Slip into the solar system, swing around the Sun, give us a brief window for study, and quietly vanish back into deep space. But within just a few weeks, it became clear that Atlas wasn't following that script at all. The data started contradicting expectations, research papers pushed competing explanations, and the astronomical community began to split as the usual natural models stopped fitting what was being observed. Then something even stranger happened. US Congresswoman Anna Paulina Luna publicly demanded that the Pentagon, not NASA, release all classified data related to Atlas. The obvious question followed immediately. Why would the military hold secret information on something officially described as a comet? And why would congressional pressure even be necessary? NASA's communication since then has been minimal and evasive, limited to sparse technical notes that avoid the core questions scientists and amateurs are raising. That silence has created a vacuum filled with speculation, and in that growing uncertainty, one line keeps circulating across astronomy forums and private researcher chats. We're not saying it's a spacecraft, we're saying a comet doesn't behave like this. Different observers, different instruments, different nights, yet all pointing to the same uncomfortable truth. Something about Atlas simply doesn't fit the comet explanation.
Diego Santaraujo isn't a professional astronomer. He's an enthusiast with a decent telescope and a passion for capturing celestial objects. When Atlas came within range, he pointed his equipment at it and started taking pictures. What he captured has become one of the most controversial pieces of evidence in this entire story. The images show an object with defined edges, not the fuzzy, amorphous blob you'd expect from a comet's nucleus surrounded by a cloud of sublimating gas. These are clean lines, sharp boundaries, a structure that holds its shape across multiple nights of observation. There's a three-dimensional quality to it, like you're looking at a solid, manufactured object rather than a fragile ball of ice and rock. After perihelion, the closest approach to the Sun, comets typically start to break apart. The intense heat stresses the structure. Cracks form, pieces carve off, the nucleus fragments. But Atlas? It remained intact. The same shape, the same structure. No visible degradation. It passed through the most extreme environment it would encounter in our solar system and emerged looking exactly the same as when it went in. And then there's the comparison that's become impossible to ignore. NASA released images of Atlas taken by professional equipment, by space-based telescopes, by instruments that should produce far superior results to anything an amateur could achieve. But the NASA images are blurred. They're processed in ways that obscure detail. They show a fuzzy patch of light without the structural definition that San Arujo captured. The astronomy community online erupted. Why does the amateur have better images than NASA? What processing techniques are being applied to the official releases? And most troubling, why do the official images seem designed to hide the very details that make this object interesting? One commenter on a space forum put it bluntly: if a comet doesn't behave like a comet, at what point do we stop calling it a comet? That's when the word started appearing. Technological. Not alien, not spacecraft, not extraterrestrial, just technological. A careful word. A word that acknowledges the geometric precision, the structural integrity, the anomalous behavior, without jumping to conclusions about origin or intent. But it's a word that changes everything. Because if there's even a possibility that this object is technological in nature, then every assumption we've made needs to be reconsidered.
Let's go through what's been observed. Not speculation, not interpretation, just the raw data that multiple independent sources have confirmed. I'm going to present these in order of increasing strangeness. By the end, you'll understand why so many astronomers are quietly admitting they don't know what they're looking at. Anomaly 1. Post-perihelion brightness increase. Comets have a predictable brightness curve. As they approach the Sun, solar heating causes ice to sublimate. The coma, that cloud of gas and dust surrounding the nucleus, grows larger and reflects more sunlight. Brightness increases. After perihelion, the comet moves away from the Sun. Heating decreases, sublimation slows, the coma shrinks, brightness drops. This has been observed thousands of times. It's one of the most reliable behaviors in all of planetary science. Atlas got brighter after perihelion, 20% brighter. The light curve shows a steady increase even as the object moved away from the heat source and solar heating decreased. There's no model of cometary activity that predicts this. NASA acknowledged the brightness increase but offered no explanation. The data is there, published in observation logs, confirmed by multiple observers. The object is producing more light as it moves away from the heat source. That's not how passive sublimation works. And the quality of the light is strange too. It's steady, stable, without the fluctuations you'd expect from random outgassing or rotating surface features. The brightness curve looks almost artificial in its consistency, like a controlled emission rather than a natural process. Anomaly 2, non-gravitational acceleration without outgassing. When comets sublimate, the escaping gas creates a rocket effect. It's called non-gravitational acceleration. The comet's trajectory changes slightly because the escaping material pushes it in a specific direction. This effect is well understood. We can measure it. We can predict it based on the amount of outgassing visible in the coma and tail. Atlas is exhibiting non-gravitational acceleration. NASA confirmed this.
The object is deviating from a purely gravitational trajectory. It's being pushed by something. But here's the problem. There's no visible outgassing, no dust jets, no expanding coma, no material escaping from the surface in quantities large enough to produce the measured acceleration. NASA's official statement acknowledged the acceleration, but provided no mechanism. That's extraordinary. In over a century of studying comets, we've never observed non-gravitational acceleration without a corresponding visible source of thrust. It's like watching a car accelerate without seeing the engine run. The effect is there. The cause is missing. A.V. Loeb, the former chair of Harvard's astronomy department, stated plainly that non-gravitational acceleration without visible outgassing is consistent with artificial propulsion. Not proof of it, consistent with it. And in science, when natural explanations fail, you're obliged to consider alternatives, no matter how uncomfortable they make you. Anomaly 3. The anti-tail. Comet tails point away from the sun, always. The solar wind pushes material outward. That's basic physics. Even when a comet is moving away from the sun, the tail still points outward, because the solar wind is always blowing radially away from our star. Atlas has jets pointing toward the sun. Observers have documented directional material emissions that move sunward against the solar wind. This is nearly impossible for a natural comet. To overcome the pressure of the solar wind requires massive force. The jets would need to be expelling material at velocities high enough to fight through that constant outward push. And there's no mechanism in cometary science that produces that kind of directed, high-velocity ejection. The images show these jets clearly. They're not artifacts of image processing. They're not optical illusions caused by viewing angle. Multiple observers from different locations have captured the same phenomenon. Material moving toward the sun when it should be moving away. Anomaly 4. Stable jet orientation. Comets rotate. As they rotate, any jets or outgassing vents on their surface sweep through space, creating changing patterns in the coma. You see this in time-lapse observations. The jets move. They trace arcs across the surrounding cloud of material. This variability is one of the key signatures that tell us we're looking at a rotating, uneven surface with localized active regions. Atlas has jets that don't move. They're stable, fixed, pointing in consistent directions regardless of how much time passes. If the object is rotating, the jets should sweep. They don't. They remain oriented as if they're locked to a specific direction, as if something is controlling the orientation of the entire object to keep those jets pointing where they need to point. Loeb has called this a possible sign of orientation control. That's a technical term. It means something is actively stabilizing the object's rotation to maintain a specific attitude in space. Satellites do this, spacecraft do this, comets don't do this. Comets tumble chaotically, influenced by the uneven thrust from random outgassing. But Atlas, it holds steady. Anomaly 5. Survival of X-class solar flares. During Atlas's approach, the Sun released several X-class flares. These are the most powerful solar events, releasing massive amounts of radiation and charged particles. They can strip away a comet's coma. They can superheat surface material. They've been observed destroying smaller comets entirely, turning them from solid objects into expanding clouds of debris. Atlas flew through these flares. It showed no response, no increase in brightness that would indicate sudden heating, no fragmentation, no change in trajectory that would suggest structural damage. It behaved like an object with significant structural integrity, not a fragile aggregate of ice and dust loosely held together by its own weak gravity. One astronomer, who asked not to be named, said in a forum post, "I've watched comets for 30 years.
I've never seen one ignore an X-class flare. They always react, always, except this one. Official science is silent on this point. No papers have been published explaining how Atlas remained intact. The data exists, multiple observatories recorded it, but no one has offered a model that accounts for this level of durability in a natural comet. Walter, an astronomer operating out of Chile, has been tracking Atlas with high-quality equipment and multiple filter bands. His observations have added another layer of strangeness to an already anomalous object. What he captured isn't just unusual, it's almost impossible to reconcile with natural processes. First, the symmetry. Across multiple nights, using different filters, the object shows near-perfect bilateral symmetry. Not approximate symmetry, not the kind of rough balance you might see in a natural object shaped by accretion and gravitational forces. This is geometric precision, the kind of symmetry that suggests design rather than random formation. Second, the absence of a tail in every filter band. Walter observed in visible light, near-infrared, and with specialized narrowband filters designed to highlight specific emissions like ionized gas or dust reflection. In every single image, Atlas appears as a compact, sharply defined object without the extended tail structure that defines comets. This isn't an observational limitation. This is an object that simply isn't producing a tail. Third, the coma is wrong. When comets develop a coma, the cloud of gas and dust expands outward from the nucleus in an irregular, fuzzy envelope. It's diffuse. It changes shape based on solar wind pressure and the rotation of the nucleus. Walter's images show a coma that's dense, static, and maintains a consistent geometric boundary. It looks less like a natural cloud of sublimated material and more like a shell or field surrounding the central object. Fourth, and this is where it gets truly strange, the emission spectrum doesn't match solar reflection. Comets shine because they reflect sunlight. The coma glows because the sun's light scatters off dust particles and excites gas molecules. But portions of Atlas's light signature suggest self-emission, not reflection, not scattered sunlight. Something about the object itself is producing light. Walter wrote in his observation log, "This object is not sublimating in any conventional sense. If it's a comet, it's unlike any comet I've observed in 2 decades of work. The structure is too stable, the emissions are too controlled. It looks less like a natural object and more like an active structure wrapped in a protective envelope."
That language is careful. Astronomers don't lightly suggest that something might be artificial, but the observations are pushing them toward conclusions they never expected to consider. The radio signal, the detail no one wants to talk about. On the same night that Walter captured his most detailed images, a radio signal was detected. Frequency 8.4 gigahertz. This is the same frequency that had been noted in earlier observations of 3I Atlas, but those detections were ambiguous, potentially explained by background noise or instrumental artifacts. This detection was different. It was simultaneous with the photographic observation. Same time window, same pointing direction. The correlation is impossible to ignore. An 8.4 gigahertz isn't a random frequency. It's in the X-band, commonly used for deep space communication because it penetrates Earth's atmosphere with minimal attenuation. NASA uses it, the European Space Agency uses it. It's a practical choice for long-distance signal transmission. No one is claiming this is an alien broadcast. That would be irresponsible. But the word that keeps appearing in discussions is synchronicity. The timing is too precise, a radio emission at a communication-relevant frequency occurring at the exact moment when the object is being photographed at its most geometrically precise. Coincidence? Maybe. But coincidences are supposed to be rare. What makes this even more unsettling is the response, or lack thereof, from official channels. When asked about the radio detection, NASA representatives said they were reviewing the data. That was weeks ago. No follow-up. No published analysis, no acknowledgement that this detection might be significant enough to warrant immediate investigation. The scientific community is trained to be cautious, to avoid jumping to conclusions, to demand multiple confirmations before accepting unusual claims. But caution is starting to look like avoidance, and avoidance makes people wonder what's being avoided.
We're now in a strange position. Two completely different interpretations of the same data, both defended by credentialed scientists, both claiming to be consistent with observations. Let me lay them out clearly so you understand what's at stake. Proponents of the natural explanation argue that Atlas is a metal-enriched comet, similar in composition to CR chondrites. These are a rare class of carbonaceous meteorites with unusual chemical properties. If Atlas formed from similar material, that could explain some of the anomalies. The high metal content would increase structural integrity, allowing it to survive solar flares. The unusual chemistry might produce gas emissions that don't create visible tails in the same way ordinary comets do. They point to something called the Fischer-Tropsch reaction. In specific environments with the right catalysts, carbon monoxide and hydrogen can combine to form complex hydrocarbons. If this reaction occurred inside Atlas, it could explain the chemical signatures detected in spectroscopic analysis. It's an exotic process, but it's natural. It's real chemistry that happens under the right conditions. As for the non-gravitational acceleration without visible outgassing, they suggest the sublimation might be occurring below the visual detection threshold. Perhaps the gas is escaping from the night side of the object, away from our line of sight. Perhaps it's a slow leak rather than explosive venting, producing thrust without creating a visible plume. This explanation has the advantage of requiring no new physics. Everything can be explained, they argue, by rare but natural processes combined with observational limitations. We've only studied 3 interstellar objects. We shouldn't be surprised that they show unusual properties. The universe is vast. Strange but natural things exist. The alternative interpretation, most vocally defended by Avi Loeb, argues that the observational evidence points toward artificial origin. Not because we've seen aliens, not because there's a smoking gun, but because the simplest explanation that accounts for all the data is that Atlas is a manufactured object. Consider the evidence. Geometric structure that holds its form across thermal stress. Non-gravitational acceleration without corresponding mass loss. Precisely oriented jets that don't sweep with rotation. Trajectory corrections that appear deliberate. Survival of radiation that should destroy a natural comet. Each of these could be explained away individually with exotic natural processes. But together, Loeb argues, they form a pattern. And that pattern looks like engineering. The jets look like thrusters. The stable orientation looks like attitude control. The trajectory corrections look like navigation. Loeb has gone further, suggesting specific functions. He proposes that the jets aren't random vents, but directed propulsion systems. That the stability isn't coincidence, but active stabilization. That the object isn't just passing through our solar system randomly, but following a calculated path. And that path, according to Loeb's analysis, is taking it directly toward Jupiter. This is where the story escalates from interesting to genuinely unsettling. Because if you plot the trajectory of Atlas beyond its perihelion passage, accounting for the observed non-gravitational acceleration, the object is heading toward Jupiter. Not near Jupiter, not in the general vicinity. It's on a course that will take it deep into Jupiter's sphere of influence. Loeb has calculated that Atlas will enter Jupiter's Hill sphere, the region where Jupiter's gravity dominates over the Sun's, in the spring of 2026. And here's where it gets specific. The trajectory isn't a random gravitational slingshot. It's optimized. The approach angle, the velocity, the timing all suggest this isn't an accidental encounter but a planned maneuver. What could it be planning? Loeb has proposed something that sounds like science fiction but is based on solid orbital mechanics. He suggests the object might deploy a swarm of autonomous probes into Jupiter's atmosphere, that it might be using Jupiter as a base, exploiting the planet's massive gravity well and rich chemical environment, that it could establish what he calls a flying base in the stable atmospheric layers of a gas giant. Why would anything do that? Because Jupiter is an ideal location for long-term observation of the inner solar system. It's gravitationally dominant, it's resource-rich if you can harvest atmospheric gases, and it's far enough from the Sun that any technology operating there would avoid the thermal stress of the inner planets while maintaining a clear view of everything happening closer in. The precision of the maneuver is what troubles even skeptics. After perihelion, Atlas executed a trajectory correction, not a gradual drift, a correction. The deviation from a purely gravitational path occurred at exactly the right time to adjust the Jupiter approach. The margin of error? Approximately 60,000 kilometers. That sounds like a lot until you realize that at interplanetary scales, that's threading a needle. That's precision on par with human spacecraft navigation.
Critics argue this is coincidence, that Loeb is seeing patterns in noise, that with enough data points you can always find apparent precision that's actually just chance. But they also admit, quietly, in papers that bury the admission in footnotes, that the trajectory did change, that the timing was optimal for a Jupiter approach, that the math works. One astronomer who declined to be named said, "I can't accept that it's artificial. I can't accept that. But I also can't explain why a comet would need to maneuver toward Jupiter with such precision. So I'm stuck, and I hate being stuck." While the astronomical data has been accumulating, something else has been happening. A strange pattern of information control and selective disclosure that's making transparency advocates increasingly vocal. Congresswoman Anna Paulina Luna submitted a formal request to the Pentagon demanding release of all military data on Atlas. Not a casual inquiry, a formal congressional demand. Her statement was unambiguous. The American people have a right to know what our defense systems have observed regarding this object. Why would the Pentagon have data on a comet? Because US Space Force and various military satellite systems track everything in near-Earth space. They have sensors that monitor for threats, and at some point, Atlas was significant enough to warrant military attention. What did they see? What data do they have that hasn't been shared with civilian astronomers? The response has been silence. No data release, no acknowledgement of what military systems observed. Just the standard response that information is being reviewed through appropriate channels. That review has been ongoing for weeks. No timeline for completion has been provided. Meanwhile, NASA's public updates have been minimal. Occasional technical bulletins, orbital parameters. Nothing that addresses the anomalies being discussed in astronomical journals and online forums. The images released by NASA remain lower quality than those captured by amateurs. The press releases are brief, clinical, stripped of anything that might generate public interest or concern. This creates a vacuum, and that vacuum is being filled by people looking at the publicly available data and asking obvious questions. Why are amateur images clearer than NASA's? What processing is being applied to official releases? What data exists that we're not seeing? The lack of transparency is creating exactly the kind of environment where conspiracy theories flourish. And here's the problem. Some of those theories are starting to sound more plausible than the official explanations. When the amateur astronomer has better images than the space agency, when military data is classified, when congressional requests are ignored, people start to wonder if the official silence is protecting something. Not aliens, not necessarily, but something that doesn't fit the narrative being presented.
Anatoly Kiselev, a researcher who's been analyzing the trajectory and velocity data, has proposed several origin scenarios for 3I Atlas. This is important because where an object comes from tells us about the environment that formed it and what it might be. The leading hypothesis places 3I Atlas's origin in the Scutum Centaurus arm of the Milky Way. This is a region of active star formation with young stellar systems where planetary formation is ongoing. If 3I Atlas was ejected from a young system in that region, it would have been traveling for hundreds of millions of years to reach us, long enough to be shaped by cosmic radiation, long enough to be an ancient relic of a stellar environment that might look very different now. Another possibility is ejection from a mature system. If a planetary system underwent gravitational instability, large planets migrating inward, outer system objects could be flung into interstellar space at high velocities. Those objects would carry the chemical signature of their birth environment, but they'd be frozen, inactive, until they encountered another star. The least likely, but most intriguing possibility is extragalactic origin. If 3I Atlas came from beyond the Milky Way, if it somehow survived the journey through intergalactic space, it would be older than almost anything we've encountered, billions of years old, a survivor from an entirely different galactic environment. Kiselev's analysis favors the Scutum Centaurus origin, but he emphasizes that without spectroscopic data showing specific isotope ratios, we can't know for certain. And that spectroscopic data, NASA has it. The James Webb Telescope observed 3I Atlas. The data exists. It hasn't been fully released.
But regardless of where it came from, the question that matters now is what it's doing here. Because origin doesn't explain behavior. Knowing where a comet came from doesn't tell you why it maneuvers, why it maintains stable orientation, why it brightens after perihelion. Those are questions about intent, not origin. And intent requires something making decisions. Atlas is approximately 300 million kilometers from Earth. That distance is decreasing by roughly 2 million kilometers per day. The object is on a trajectory that will bring it to minimum approach distance on December 19th. That's not far away. That's happening soon. What will we see when it gets closer? Will amateur astronomers capture even more detailed images, showing structure that NASA's blurred releases obscure? Will the object's behavior change as it moves into different regions of the solar system's magnetic environment? Will there be more radio detections, more trajectory corrections, more evidence that this isn't a passive chunk of ice and rock? The anticipation in the astronomical community is palpable. Every observatory with the right equipment is preparing observation schedules. Radio telescopes are being pointed at the predicted coordinates. Spectrographs are ready to analyze any changes in emission signatures. And then there's Jupiter. Spring 2026. The calculated arrival at Jupiter's Hill sphere. If Loeb is right, if this object is executing a deliberate maneuver, that's when we'll know. That's when the trajectory will either continue on a natural path or do something that no natural object should do. The question hanging in the air is simple but profound. If this is a comet, why is it doing everything that comets can't do? No one has answered that question yet. The natural explanations keep failing. The exotic chemistry arguments keep requiring more and more unlikely coincidences. The observational data keeps accumulating in ways that make the comet hypothesis harder to defend. But the alternative is deeply uncomfortable, because accepting that Atlas might be artificial means accepting that we're being visited, that something from beyond our solar system, from another star system, possibly from another civilization, is here. Not landing, not communicating, just observing, moving through our system with apparent purpose. And if that's true, If this object is technological, then every assumption we've made about our place in the universe needs revision. Let me summarize what we know with certainty. ATLS is an interstellar object confirmed to have originated beyond our solar system. It exhibits geometric structure that remains stable across thermal stress. It shows non-gravitational acceleration without corresponding visible mass loss. Its jets maintain fixed orientation inconsistent with tumbling rotation. It survived X-class solar flares that should have destroyed a natural comet. It brightened after perihelion when it should have dimmed. Its trajectory appears optimized for a Jupiter encounter. Each of these observations has been documented. Each has been confirmed by multiple independent sources. This isn't speculation, this is data.
The natural explanation requires accepting that we're witnessing the most unusual comet ever observed. That every anomaly can be explained by rare but possible natural processes. That the apparent patterns are coincidences. That our sample size of interstellar objects is too small to know what's normal. The artificial explanation requires accepting that manufactured objects can traverse interstellar space, that another technological civilization exists or existed, that we're capable of detecting such objects with current instruments, that we're not alone. Both explanations require accepting something that challenges our existing understanding. The question is, which challenge is more reasonable? NASA has one of the most sophisticated public outreach programs in the world. When Perseverance landed on Mars, we got daily updates. When James Webb captured its first images, they were released immediately, with detailed explanations. NASA excels at making science accessible and exciting. But with Atlas, the communication strategy has been different. Minimal releases, technical updates without context, images that somehow show less detail than amateur observations, no press conferences, no explanatory videos, no effort to address the anomalies being discussed across scientific forums. Why the difference? What makes this object deserving of less public engagement rather than more? Is it simply that the data is too uncertain? The interpretation's too controversial? Or is there something about Atlas that NASA finds difficult to explain in ways that don't generate uncomfortable questions?
The pattern is clear. Maximum information control, minimum public disclosure. Amateur astronomers releasing better data than the official sources. Military systems tracking the object with classified observations. Congressional inquiries being stonewalled. This isn't how science is supposed to work. This is how information management works when the truth is complicated. The clustering of anomalies around Atlas has reached a point where coincidence is starting to sound like willful denial. Geometric structure, stable orientation, trajectory corrections, Jupiter maneuver, radio signals, post-perihelion brightening, flare survival, each individually defensible as natural, all together forming a pattern that's hard to dismiss. Science requires skepticism. It demands rigorous standards before accepting extraordinary claims. But it also requires intellectual honesty. When the data consistently points in a direction you don't want to go, you don't get to ignore it because the implications are uncomfortable. And the implications of Atlas are deeply uncomfortable. Because if this object is technological, it means we're not alone. It means interstellar travel is possible. It means something is here, in our solar system, right now, potentially observing us while we debate whether it's real. The silence from NASA, the classified military data, the congressional pressure for disclosure, the amateur images showing structure that official releases obscure. These aren't the signatures of a straightforward scientific mystery being investigated openly. These are the signatures of an information control operation managing a revelation that someone, somewhere, has decided we're not ready for.
Atlas is exhibiting behavior consistent with a unified, structurally robust, possibly controlled object. The scientific explanation exists: metal-rich comet, exotic chemistry, rare but natural processes. But every week brings new observations that strain that explanation further. Too much precision in the trajectory, too much stability in the structure, too much silence from official sources, too much evidence that something about this object doesn't fit our understanding of what interstellar visitors should be. The answer isn't here yet, but the object is getting closer. As it approaches minimum distance in mid-December, as amateur astronomers point their telescopes at it with equipment that somehow captures clearer images than NASA releases, as the Jupiter encounter approaches in spring 2026, the truth will become harder to obscure. Because if this is a comet, it's the most anomalous comet ever observed. And if it's not a comet, if it's something else, then everything we thought we understood about our isolation in the universe is about to change. The data is accumulating, the anomalies are multiplying, the silence from official sources is becoming more conspicuous with every passing day. Atlas is not behaving like a comet. It's behaving like something that knows where it's going. And that's the truth that's hardest to accept. Because if it knows where it's going, something made it, something designed it, something sent it here. And we're about to find out what happens when it arrives.